Hi guys, so this is going to start all of your videos for your spring semester exam review. I will title them with all the numbers that I get through so that way you know which video to reference when you are looking for help for your final exam review. Hopefully a lot of you don't have to take this exam because you're exempt, but like I said, you will figure that out from Mrs. Wilkes. And those of you that do have to take the exam, if you have questions, please refer to these videos. Because remember, Mrs. Wilkes wasn't here the whole semester, so she doesn't know what we covered from January until April before she started taking over, okay? So let's go ahead and get started. So the first 16 problems are going to be some true-false statements that you should know, and I'll go ahead and correct some of them for you to help you out with those if we need help with those. So the first one, the 50th percentile of a normal distribution is the mean of the distribution. So remember, 50th percentile means at 50% or below, and that value that you're at is the mean because you're right in the middle. So that's true. Number two, for all normal curves, approximately 99.7% of all observations fall within 2 standard deviations. So remember, back when we did normal curves, we went 3 standard deviations above and 3 standard deviations below. Well, the reason why we went 3 is because that's where the majority of the data falls. Not even majority, where virtually all of the data falls is within 3 standard deviations of the mean. So that is false because it's 3 standard deviations. Number 3, as the sample size increases, the standard deviation of the sampling distribution increases. So remember, as sample size goes up and up and up, your standard deviation, which relates to the spread of the curve, is not going to increase. If we keep getting more and more data, then the standard deviation is going to decrease because you're going to become more concise around one value. That means it's going to make the graph more tall and skinny there. So that is also false. Number 4, the point estimate is the value that determines the center of the confidence interval. That is true. Remember that we talked about 2 point estimates. We talked about p hat and x bar. So those are both point estimates. It just depends, are you doing a confidence interval for means or for proportions? So either way, that will be the center of the confidence interval. Number 5, when creating a confidence interval, the size of the sample is irrelevant. That's definitely not true, right? For both means and proportions, we had to check that our sample size met a certain requirement. For means, we had to be greater than or equal to 30. And for proportions, you had to check that n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So that way you could compute the confidence interval because then it was approximately normal. So just depends if you're doing proportions or means, but we had a couple checks that we did this semester to double check the sample size. So sample size definitely is a requirement you have to meet in order to create a confidence interval. Number 6, when performing a confidence interval or hypothesis test inference procedure, it doesn't matter if the data came from a random sample. Thanks to all of our condition checks we did for 4 units in a row, you guys should know that is definitely false. You have to have a random sample. That's one of the conditions. One of the conditions. So no matter which test you were doing, it didn't matter. We had to meet that. Number 7, when creating confidence intervals, the sampling distribution can be skewed. So number 7, that is not true. For confidence intervals, the shape that we want is not skewed. We want approximately normal. And depending on what procedure you are applying, whether it's proportions or means, the way you show something's approximately normal may be different, but the fact is we have to have it be approximately normal to create a confidence interval. So that is going to be false. Number 8, it is customary to say that the result of a hypothesis test is statistically significant when the p-value is smaller than A. So if my p-value is smaller technically or equal to A, remember that means that it's unlikely to happen. And if something's unlikely to happen, that is what we call statistically significant. So that is true. So that just means, wow, we found something that's so unlikely that there might be another cause for that. So that's why it's statistically significant. Okay, number 9, given a level of significance of 0.05, which is the only level of significance that we'll use for alpha, a p-value of 0.05, the decision for a hypothesis test would be reject the null. So since my p-value of 0.05 is less than or equal to alpha, which is 0.05, remember it can equal, then you would reject the null because it's so unlikely that you do reject the null hypothesis. Number 10, when n is large, so n is greater than or equal to 30, a t-distribution, remember t-distributions we use with means, okay, will become approximately normal even if the population the sample is pulled from is strongly skewed right. Remember, once we meet this sample size requirement, it doesn't matter what shape the original data came from. We have enough in our sample size to say that the t-distribution will become approximately normal. So that is true. Let's see, number 11, if the p-value is more than the significance level, so if my p-value is greater than alpha, then we would accept the null hypothesis as true. Okay, remember, if it's greater than alpha, that means you fail to reject the null hypothesis, but that doesn't mean you accept the null hypothesis. Remember, it's just like the murder trial. We are never going to say that if we don't get enough evidence that that person is innocent. We just say they're not guilty because we didn't get enough evidence. So remember, we don't ever at the end of a trial say someone's innocent, just like you'll never accept the null hypothesis. You just fail to reject it. So that is false. Number 12, the sampling distribution of X bar is always normal when the population being sampled follows a normal distribution. That's going to be true. So if the sample is normal, then the sampling distribution will also be normal. That's just one of our rules that we talked about to show that something's approximately normal for a t-distribution. Number 13, reducing the sample size will increase bias. So for number 13, if you guys remember, this is actually going all the way back to our very first unit of this semester. Sample size and bias don't really have a hand-in-hand correlation, so that's false. Okay. Bias can be reduced by some sort of random sampling method. That's definitely true. Remember, a big concept we talked about is how randomization reduces bias. 15, variation, which is also known as spread, is reduced by increasing the sample size. This is just like number 3 up above. So if you increase sample size, standard deviation will decrease. Well, standard deviation is a form of variation. So that's kind of the same question, but you should know that if you increase sample size, the spread of a distribution will be reduced. That's true. And 16, when the person asking the questions could influence you to answer a certain way, that is called response bias. So if you're talking to a certain person and you may lie or give wrong answers, that's exactly the definition of response bias. And that is all of your true false. Let's see where we're at with time. So that was perfect. So 1 through 16, the true false was handled in our very first video. So in the next video, we'll start up on page 2, which will be 17 through 22, but we may get through a little bit more than that in the second video.